webinar on T6.0 using System.Xml to manage XML. This is your host, Matt Brunquell, and with me today doing this presentation is Jean-Marc Gamperl. Before we get started, though, I want to review a few items. For those new to Unify Corporation, we're a publicly traded software company that's been in business for over 30 years, and we're known for being the first to deliver a relational database in a Unix environment. But then we've delivered development software products that run across different databases and platforms geared towards building and modernizing business applications, and to the business application developer who places a premium on productivity over low-level coding. Our business has expanded beyond base and development products into migration solutions, as well as archiving and e-discovery as well. But our focus is going to be on one of our premier development tools for the business application developer, which is Team Developer, and in particular Team Developer 6. Now, we answer questions on the webinar, and the way you do that is to use the Q&A button on your WebEx toolbar. It's the button with the question mark. And there's no chat button, but it just makes it easier for Jean-Marc and I to look in the one panel for questions to make sure we address all of them. Now, I mentioned Jean-Marc. He's our presenter today. He is one of our senior technical support engineers, and he has been with Unify for many, many years, and that's including his history at Gupta, his technical roles. But most folks that are on today, if you're an existing customer, you probably know him from his role in support. He spent a lot of time working with Team Developer customers since some very old versions, helping them migrate up to the latest release. So someone with a lot of experience, not just from the Gupta and internal side, but really working with the customers on their applications and getting them over. And getting quite familiar with the .NET aspects as well that that have really opened up to developers in Team Developer 6, and that's why we have them presenting today on using the System.Xml to manage XML. So just a great opportunity to have someone with his experience doing that today. So definitely take advantage of it. Ask him questions. And with that, I'm going to turn it over to Jean-Marc. Thanks, Mark.
So today we are going to discuss, as Matt said, TD6 using System.Xml to manage XML. The first thing I like to say here in this title is "Oh my God." The "Oh my God" would be for XML, because you probably already, all of you are developer, heard about XML, and it's quite huge. It's a set of family of technology. It's truly huge, and actually I'm not a developer, and what I try to say is that if you use XML, you really have to practice XML to be actually fluent, like if you would be fluent with a language, because actually it's a language, and there is a lot of tools and technology around XML. I'm quite verifying more and more with the system dot over here, which would mean that we would consume actually assemblies, and notably here System.Xml. So let's get started, and we have to start from somewhere. Some people might already know XML for sure. You all of you heard about XML. It's a very important technology, and we have to, or at least for myself, I want to restate some points about what is XML. XML also have components, the language, there are rules, and I like also to touch base very quickly on XML components. And then we're going to have some .NET concepts. Actually, the previous webinar was also about consuming assembly. In this case, we're going to strictly talk about XML. Then we're going to talk about Net System XML documents, so the DOM object, the aspect of DOM, and we'll see how to actually read an XML file and basically open any XML file and recursively parsing it. So there's going to be a demo on that one. Then we're going to talk about getting specific data, knowing the XML. You can directly navigate to the data that you're interested. So that's going to be another example. And then we're going to stories about different engines that exist and the current engines that you can use in Team Developer if we're not talking about .NET. It's quite important and has some implication for migration. Then we're going to talk about some other engines because there are multiple XML engines. XML Reader and Writer is a quite interesting object, which are also actually to parse and to write an XML file. All that will have some implication about performance as we will see it. Also, the demo that I put there, actually an application that I did that I'm quite happy with it. We show you use XML Reader and Writer how to export, how to read XML file in a grid and how to write it, and quite interestingly also how to retrieve a data set from a .NET assembly, which is a store procedure that would return a data set, and all that, but in the grid. And finally, we're gonna go through question and answer. So XML in some points, I like to say here some points because probably the people that know well XML already saw a lot of literature on the internet. Actually, there could be 10 points from the XML org. So the first thing you have to know is that XML is for structuring data. If you want to deal with address book, configuration parameter, or more, it becomes a tendency, and more you see people using XML. People tend to stop using any file or their own custom settings simply because XML became a standard and is massively used by all the industry. Looks like HTML, so if you know about HTML, you know that use tags, brackets, and attributes which have value. Tags delimit pieces of data. And what is important is then the interpretation of the data that you have in an XML file is left to the application, right? XML also is a text format, so you're not really supposed to read XML, but the advantage is that if you really need to, for example, debugging or just a look of the data, you can always use any text editor and watch out this contents. As long as you understand the rule of XML, you'll be at home and you'll understand the way the data are structured. There is a family of technology. This is where I say, oh my God, because talking about XML and System.Xml includes a lot of things. So we're going to refrain ourselves to talk about XML 1.0 because it's impossible to talk more about it, in a webinar of maximum 45 minutes. So you have links that describe a standard way to add hyperlink to an XML file, XPointer, which is a syntax in development for pointing part of an XML document. There is also XPath, as far as I know. There is XSL, extensible style sheet, and XSLT. That seems to be quite complicated. It's about to make a transformation of XML to HTML, and it's quite, at least to me, I'm support again, I'm not a developer, a quite complicated subject. And then that's all the reason we're talking today is to talk about the DOM, the Document Object Model, which is a standard set of functions to call and to manipulate XML, and also actually HTML. There is actually also a way to open an HTML and to deal with it through a document object. XML schema, it's for constraints, normalization, and defaulting on the document. We are not going to talk about XML schema, neither validation. So XML is quite a new technology, but not that new. Actually, neither in Team Developer. People could use XML back in Team Developer 1.5.1, where there was the ActiveX object, MSXML. But before XML, there was SGML, which stands for Standardized Markup Language. Then HTML, and then finally XML. And so it's a quite mature technology, simply because it takes the best of SGML, so you have all the power of the SGML plus the experience built up on HTML. But we kind of know what XML is about. We have to know what are the components of XML. So most important components is the element components, which is case sensitive and must start with a letter. It includes everything from start tags, end tags, and empty element. So over here, for example, you have an empty element, right? And this is a start tag, which this also is. Element can contain other elements. Over here, you have the table element, which contains other elements. You have text in XML, which is the area over here. You have attribute over there. I don't have attributes, right? But we'll see attributes later on, or a mix of all the above. The element object is also a node. The word node is going to have its importance when we're going to talk about DOM. Important, text is always stored in a text node. A common error in the DOM processing is to navigate to an element node and expect it to contain the text. To look at the employee ID AHT, the tag, there is an element node employee ID, and just under it there is actually the text. So the common mistake is just to navigate on the first node, which is text, and in fact not get what you're expecting. There are other components quite important, especially when the intent of XML is to share file and data. You won't share it across the world. So generally, you would use UTF so that you can just send an XML file, encoded, so that it supports, all the character set of the country. So you can find the encoding like UTF-8. You also have UTF-16. It contains information about structure and style sheet. So structure style sheet ain't going to be covered over there. The only things you're seeing is that I have an XML version 1.0, which is using the encoding UTF-8. It's very simple. Everybody in a programming language needs to know about comments. In Excel, you can also set comments. Basically, we'll tell the engine, the XML engine, to not parse what you put in comment. Actually, for your information, just to tell you that XML is very important. If you are a developer, there's no way you can know XML. And if you don't have projects using XML, well, I encourage you actually to get more and more practice on it, because it's absolutely mandatory. So just for the information over here, you can see that I commented here. If you this comment here is because we are using Wix, which is an installer which is fully based on XML, and that's using in support to create our EMP. Components, you have text, as I mentioned in the previous slide. XML supports Unicode, also because the data exchange is very important with it, all the standard that XML gives you. So it supports obviously a range of character, later digit, punctuation, and symbol. Most contextual and Unicode characters are not allowed because XML relies on the brackets and the ampersand to delimit the markup. You represent this char if you need to using character and entity reference. Sounds a very complicated term, or C data. In fact, it's not that complicated, because the entity and entity reference over here are, for example, ampersand emp, and here less than greater than, which if you type this in a text editor and if you open the XML, resulting XML that you save, for example, in Internet Explorer, this is the result you're going to get. It's a kind of way of escaping. I don't know if the technical term is correct here for XML. So instead of using entities all over the place, and if you need to put a section that must not be parsed, you're going to use C data, which stands for unparsed character data, versus the parsed character data. Parsed because element might contain other elements. So this is why, if you need, for example, to put a script or all character that might not be pro to have in an XML file, then you would use a C data section over here. That's the way you use it, and that's going to be the end result. Again, if you create this file in Notepad and save it and open it on the Internet Explorer, you're going to see this result. Attributes is to add information about an element, or used to define property of element, and considered as the data of the element. Attribute must be quoted. Over here I have an attribute. Attribute issues. Generally, there might be some discussion as whether it's good to use attribute. Actually, here I have an example where the person make everything an attribute, right? And this is really bad. You better use this actually to structure your XML. Use a node ID and then the ID reference assigned to elements. Basically, you're using metadata. Metadata is a very ambiguous term. People refer it as data about data. So you have to be careful when you're using attributes, simply because there are some limitations when you're using attributes. Now, I say that I will not really talk about validation, but it's still important to mention that XML, again, is a set of technology. It's important to ensure that you have a well-formed document. So a well-formed document is any XML that you would write contain a root element which has have closing tags which are case sensitive. Tags are case sensitive. XML element must be properly nested, and attribute value must be quoted. If you have that, and if you follow the rule of XML, then you have, as we say, a well-formed XML. If you type an XML to a file called a DTT, document type definition, then you can refer it as a valid XML, because you're going to have some information, get the engine, for example, to DOM, to ensure that, for example, the note element contains, the element to, from, eating, and body. All right, and so well-formed XML plus DTT would be seen as a valid XML document. We don't talk much about this from now on. So all this so far has been a kind of a pleasure, obviously from what I found out on the internet, just to see for myself what I understand from XML. And it's really the beginning. It's XML 1.0, so we don't talk about as a technology here. So it's only fair here, because I'm making some plagiar, that I'm referring to the information I found out there on the web. The other things you might want to read if you're interested about Team Developer and XML is that we created a couple of white paper, XML, a primer PDF, using Team Developer for XML business integration, and Team Developer and XML PDF. Actually, I did that white paper at the time for Team Developer 4.2, because, as I say, XML is not new, even in Team Developer. Now that we have a bit of framework and the understanding, a really basic understanding about XML, we have to talk about now another technology, which is the .NET framework. So .NET framework is, I would refer it as a library of class, but actually it's a new technology. The framework gets installed. It's a library, or it's a set of, of libraries from Microsoft, which by default are installed on the operating system, at least Windows Vista N7 and 2008. Typically the .NET Framework 3.5, and now also the version 4. So as I say, a large library of code. People refer it as the BAS class library. I'm not going to click on this link over here because I do still have that problem that if I open this link, an hyperlink in PowerPoint, actually PowerPoint will try to use Internet Explorer, right, as opposed to Firefox, while all of the link would open in Firefox, and for some reason it hangs. But basically here you have actually the BCL. All that, the .NET framework, all that is the BCL, and this is just one little part, of the BCL, which is the System.Xml. The .NET framework includes a common language infrastructure that manages the execution of programs written for the framework, support multiple programming language to allow interoperability. Program can utilize code written in other language. All slides is actually 3-4 slide maximum. I already mentioned last week, but for the people that didn't, I already did in the previous webinar. NetAssembly is a compiled library for using deployment, versioning, and security. The versioning and security is very important. This is a strong feature of .NET as well as deployment. It consists of one or more file called module. Actually, an exe also can be an assembly. An assembly are the building blocks of .NET, so it's a huge collection of assembly that forms actually the .NET framework. NetAssembly contain code in common intermediate language, so actually a development tool will translate the human readable language into something called common intermediate language, CIL, and then it will be converted by the just-in-time compiler, to actually execute the code. NetAssembly can have version information. As I said, this is very, very important, and the way they deal with that, as opposed to COM, is much more strong and avoids, a couple problems DLL, but the DLL was strictly, interfacing a DLL. COM already improved a lot the use of DLLs through unique IDs, and NetAssembly actually we will see also have in a way some kind of unique ID that you register on the GSE. The College Runtime is the Microsoft implementation of the Common Language Infrastructure, CLI. Basically, what I want to tell you in this slide is that you can have different development tools, as we already talked about it. TD.NET, now that we support .NET Target, also we actually convert, SAL code to SIL code. And the CLI, the Common Language Runtime, and the just-in-time compiler, right, debugger, but compiler, will actually dynamically compile, your code. The net result is that this is extremely optimized. Actually, you're going to get some sense out of it when we're going to talk about performance. Okay, when we talk about assembly, we are talking about the global assembly cache, which is read as the GSE is unavoidable. Generally, you can find the assembly GSE in the Windows assembly directory. Actually, not generally, but it's where it is located. You can see version for assembly, but you can also see file versions. Those are differences. Basically, you can register if you strongly name your assembly into your GSE. If you don't do that, then generally you're going to pick up the assembly in the current directory. So let's continue. So now that we talked about very briefly about XML and now about the framework, the .NET framework, that we know that the System.Xml is part of the .NET framework, how do you consume it in Team Developer? Well, in version 6.0, we did something very, very similar to the ActiveX wizard, which allows you to generate an interface to the call method that you want to call. It's pretty much the same. We actually generate an interface so that you can actually consume assembly in Win32, which was covered in the previous webinar, but also directly with the .NET Target. So here is the video because I have a lot of file on machine and that would take some time. So I selected System.Xml, and here I'm just going to select what I need for all my presentation and demo. So I took XML document, text reader, and text writer, and then I generate the face. And the result I'm going to put in this directory. So I think very important to mention at this stage with the version 6.0, it's going to be also the case with the version 6.1, is that people that already played with the version 6.0 and the .NET Explorer knows that you can only select one assembly. If you would select two assembly and including, for example, the resulting 2 PL, you have clashes in symbol. So you cannot actually use two different assemblies. But what you can do though is one of the assembly. For example, I generate System.Xml, but I find out that, for example, I want to use a string builder. So what I do is that I remove all the code that are common to the System.Xml and only keep the string builder class. So this is something that exists in 6.0. If you target for .NET executable for an application, then you would have to deal with an AXL file, which actually is an XML file. So you're going to have to either pull in, merge, or remove symbols to have one single XML file that have all what you need to consume, or basically the import that you're interested in. Now that we talked about how to generate the interface so that we are able to call, to use objects and interfaces from the System.Xml document, we're going to talk about DOM here. So what is DOM? It allows the program and script to dynamically access and update the content of a document, including its structure and style. It provides a standard set of objects, standard set of interface for accessing document objects. XML document, because we're going to talk about .NET here, the object DOM actually is as soon as you load the document, it will be loaded in memory, and it's a representation of an XML document. As a tree in memory containing XML node, you remember that I introduced a bit node where we were talking about element, which is the base object of the DOM tree. I'm sorry here for the cut. XML document for information derived from the XML node which is the base object for the DOM. XElement also derived from XML link node, and XML link node derived from an XML node. A node can be an element node, an attribute node, a text node, or any other of the type node. Here you see, after generating through .NET Explorer, you'll see that you also get enumeration, which are some kind of constant that are grouped. For example, System.Xml node type, and over here you can see all the different node type that you can have for the XML document DOM object. If you're interested about DOM in more detail, of course, a lot of reading might be necessary. You can have specific DOM information about XML and HTML here, and specific to Microsoft XML DOM object at this URL. Okay, now the task can be to parse any XML documents using DOM. So how do you achieve that? So I'd say the first thing is to generate an interface on System.Xml, which we saw in the previous video using the .NET Explorer. Select System.Xml and XML document class, which are also shown in the video. Create the needed instance variable. So this is where our team developer application starts, and that's the code you're going to start to pull in. So you can see here that I just instantiate a document object and an element object, right? Then, obviously, you need to load this XML file into the memory, so that in the memory you have a tree with nodes that you can parse. So the method for doing that, first you have to actually initialize the object. Over here you see a constructor. Now, constructor, team developer will expose. You know that with team developer you cannot have overload methods. So overload methods, if you have multiple constructors, are called overload 1, overload 2, overload 3. With the active coding assistant and with the help of the MSDN, you can easily see what is the constructor you need. The old one here, without no parameter, is a way to actually construct the object, right? And you use it only if you are coding. Actually, you can use it with .NET, but the overload one without parameter is important if you are targeting for Win32 consuming assembly through Gale, because you need to construct the object. While .NET, if your target is only a .NET, that would be enough. But anyway, here we are loading our document and we construct our object. Then you get an instance to the document element. So that by using System.Xml element, which is the variable that we define, and we just get the document element, which will return us an object. At this point, you want to start to navigate to actually process all the nodes of your tree in memory. So we're going to process all our element nodes recursively using the call process function. We're going to pass the element, and notice that the parameter of the process function is node, but I'm passing an element. This is fine because an element object derived from System.Xml XML linked node and System.Xml node, as we talked before. So the only things you have to know now at this point is that we have a process function. That function also will have its own local System.Xml node and System.Xml named node map to process recursively all the nodes of the element found, including attribute. So they have their own local copy because our code is going to be recursive. So at the entry, so we define an XML node over here inside the function process, and an XML map, node app, which is a collection of nodes, right? And then a couple of variables that I'm sure you understand. The incident is just to hide in the XML when I'm going to display the result. So the first task you're going to have to find out if our node is our node an element or something else. So you're going to use the getNode type function, and you're going to compare it to the enumeration that I showed you previously. So basically here you want to know if we do have an element. If element type, we just get this name and the value of the node. Over here, like explanation, I will explain you in terms of performance later on. SB is a string builder class. It's just to concatenate the strings, right? We are using that because you would have quite bad performance if you would concatenate normal team developer string. Even if you would do that in .NET Visual Studio, you would get some performance penalty just concatenating the string. So this is the reason why I'm using also another object, not part of System.Xml, which is the string builder. And here I just display, the name and the value of the element. It might also contain an attribute, so getting the attribute collection of the node of the current node. Find the current node over here. I passed the element. The parameter was a node, and I'm in the current node, right? And then I want to check if I get the attribute. So the only way to do that is from the parameter passing. So I can always check with the get attribute function the attribute and actually passing a collection to a collection of nodes which represent attributes. Then at this point, you're simply going to count your attribute, and when you're going to find your attribute, we're simply going to again display it with the string builder as opposed to concatenating a string, and we're going to increment our index. Now we process the element and the attribute, but we have to process text element, right? So if it's a text element, if it is, then we get this value. So as if the passed the process function, which is recursive, is of type not type text, as you see over here, then I'm also going to display its value. So far we check our first element and display its first tag name. So right at the entry, of the process function, you're going to typically get your root element, right? But we're finished because you have the root element, you have the close tag of the root element, but inside you have many nodes, right? So you're going to have to recursively parse those because you don't know how many nodes there are. So what you're going to do is to simply use the method haveChildNode from the current node passed to the process function. We're going to check if we do have nodes, child nodes, and then if we do have a child node, we position it to our first child of the node. If we're done, we do some indentation. So the indentation is just to show you the result neatly, for example, in a list box. And recursively, we call again the process function to display the next tag, the attribute, the text value, until there is no more element to process. Return from next sibling in the document. This, is a reading. It's quite difficult sometimes to make code comments. There's nothing better than having a look in practice how this is working. So let's go to Team Developer. Let me open the samples over here, which is going to be this one. Here's the program, with the process function, with the parameter and so on. And here's the entry process. Let me set the breakpoint. Toggle point. Okay, debug Go for that guy. This is a .NET target, so it's not using Win32. Application, I'm actually executing. Time, okay. I'm going to use string because I want to see in the debugger, where we are processing our tree and nodes. So let's go to 6 and let me take the book. Okay, I'm breaking into the process. So the only things I did is to get to open the document. So overload 1 to construct the object, to open the document, so that now the document is in memory, and then get the document element, right, which is the object or XML element. You could even use a node. That wouldn't be a problem. And then I pass it to the process function, which I'm gonna step into, right? So here we are in the process function. So the first step is to check our node type. As you remember, I explained we have to check his element. So if SB equal 1, if CB1, sorry, then I want to check check the content of S. So let me step over that guy. Then you can see catalog, right, which is the root element. Then let me continue stepping inside. Now I check if there are attributes. Sorry, I go a bit too quick. There is no attribute at this point. So I'm just going to continue, checking if there are child. If there are child, I go to the first child, which is generally with a big XML, and I check if the node is null. If it's not null, then I ident, right? Because the root, and I want to go to the next level. So here's just the indentation, and then recursively I call again the process function, right? Which allows me to go. Do I have in the second recursive call XML element? Yes. Now I check this value here. It's the book, right? So from a book, there are the attributes. Yes, the attributes. So the attributes of this book is book ID 101, right? So continue to loop to check if there are attributes. There are no more, right? Then at this point, I'm back again in my call, in my recursive call. Check again the object null. I process again to the next element. And at this point, I'm going to get the tag element author. Sorry. Okay. This author will contain the text. And so let's see that. It's going to process into the recursive call. To it. It's not an element, but see, you have the first text element here. So I actually display, and so on. And then you can see that you go directly back. See, you don't go anymore in over here because we are in recursive call, right? There, and that's going to be the end. I think here. I'm not sure. Yes, that's going to be the end of this child element. Take the rest, the title, and then get yes, I get the author, and then the title next. Sorry. And, I'm gonna stop, but obviously I think you're seeing what I mean. So now I continue there. You get the resulting XML here. So the way to actually recursively parsing through your tree in memory through all the nodes, displaying the elements. Okay, see that? Generally, when you're going to deal with an XML file, pretty much its structure, and you want to go right away to its data, right? In this example, for example, we're just going to read again the same XML book file and just want to be able to get directly the information. So how do we do that? So if you do this application, as I previously, you would always instantiate the XML document, because this is the object which allow you to load the XML in memory. And the people that are familiar with ActiveX or in object-oriented programming, but especially ActiveX, often have the notion of, for example, if we talk about the object library of MS Office, of having an application object. If we talk about Excel, for which you drill down to get books and then collections of books, and then to access your spreadsheet. Here, the document object would be an equivalent of the application object of the Microsoft Office object library. Then, because we're interested to get the author, the title, the genre, etc., well, we can already instantiate all of those. You see that the application is quite simple and could be written in a much better way, but the purpose here was just for demonstration. It's actually not me that wrote it, but the reason it was done the way it is just to make it more clear. Here we have our XML, right, and we want a list of books. So basically we want book ID 101, 102, and so on. So we like to have a list, or if you prefer, a collection of all those books, right? So you're going to instantiate also a book node list, right? Or you're going to have at one point a node list when you're going to parse XML file. And in each book, the list, we want the item represented as node. So System.Xml, XML node, book node. Remember, say element is, well, it's not, a node, can be elements and are elements of type text and so on. So whenever you have there, this is in the book note that you can check if we do have text and so on. So you're going to instantiate that. So as in the previous example, as I say here, you construct the object. So you have the XML document instance variable, and you call the overload1 method. This is for GER, not needed for .NET. If you're on .NET, this would be enough. Document underscore overload1 to just load the XML file. We loaded our document in tree with our book collection, so getting an XML node list containing a list of all the standard elements that match the specified node. So this is exactly, if you go into the MSDN and check for the XML node list method, that's exactly what is written. So set book node list equal document get elements by tag name. So this is the way you get the book node list, and you're going to go right away to the book, right? So we don't care, about the root element catalog in this case. So we go directly to our data. Getting the count of the book from the book node list collection here, well, just for the sake of it, just open it in Internet Explorer. You can see that there are 12, books. Okay. Then I get the count on the collection that I have. Simply going to loop, in this collection, where I'm going to insert the row and call saltb set context. So basically, I start to read my node and start to populate my table window. Retrieve a book node at the given index. Set book node. So once that we have the book node, so I already inserted the first row in my table window, and this is where I'm going to start to get my data that I'm interested with. I'm going to get the book node, and inside that book node, I'm going to call a function getAuthor. So here I'm setting the colon, and here I'm calling the getAuthor. Then I'm calling the getTitle and so on function to actually populate my table window, and I loop until there is no more element. GetAuthor is extremely simple. It returns a string. There is a local variable string, and the action that this guy does is to call getItem overload1. So basically, go to the author element and return you the author element. You remember that we instantiate elements, the author, the title, and so on. So here we're going to have an object, an element object that represents the author. Then get the concatenate value of the node and all its children. So you will, this is actually also the description from the MSDN from that function, get inner text. You remember that at the beginning, I say that a common error in DOM is to be on the first element of a text and then think that there's value in it. Actually not. There are other elements inside the text, right? To underrate the actual text. So this is why we call it concatenated, right? Otherwise, if you would use the method getValue, you would get blank. You would get nothing, all right? And that's it, returning the text of the author element to be set in the grid. And then you turn the value to the function. Now, we want to do the same thing, setting our data, from a grid. Once the grid is populated, as you can update the grid, and then you want to modify that data. So actually, it's exactly the same as when you read, the document. You need to have, we need our book collection again. So this is exactly the same as the previous size that I showed. The only difference is going to be in the loop. We're only going to do a saltb set context. Of course, we don't create column because we want to save, right? And we're going to retrieve a book node at the given index. That's exactly the same as the previous slide. And then we're simply going to call set author and title and so on. And again, we're going to loop. Actually, here also saving every time, our XML. There might be better way of doing that. There's no need necessarily to at each moment, book XML. But this is just as an example. Function set author compared to the get author does again the same thing. Set author to get the author element, to get author element, and when you get the author element, instead of calling get, you simply call set inner text value. That's about it. So now, if I go, showing you data, let me go. It's equal with 0. let me show you the demo of that. Okay, this one. Okay. Okay. You can save this, and then you can save that, then populate it. Actually, you know, the table window was not reset, but you can clearly see that we updated, actually merged, you know, our XML file. So basically, this is the way we saw so far to recursively parsing any Excel file using DOM, and how to navigate to some data into from your XML. Now, XML DOM engine in Team Developer. I always like to talk about analogy because when I'm not very secure about a new technology, and I'm sorry to say, but I'm still not very secure with XML because, you know, I'm support, I'm not practicing everyday XML, so I'm a bit rusty about it. But, you know, I can read on the internet and I find something quite nice here. XML is a way to represent structure information as text. It has one established transform language and a couple more in design. There is no management component. Compare it to relational database is like comparing a glider to an airline. That's from the XML org. And I quite like the statement because, yes, there is no engine in an XML file. I would refer, though, to the DOM as an engine that would process, you know, the XML file. It's a bit like if you have SQL base, and if you, yes, because we are comparing it to a database, and you're making an unload file. The problem is that your unload file is only valid for SQL base, right? And then if you give it to someone else, your data through an unload file of SQL base, well, the other person needs to have SQL base, so it's not really a standard, it's our standard. So XML is truly to exchange data, right? And the engines that you have to process those data, to interpret those data, to transform them, to change styles and so on, you know, there are different engines. So, as a team developer could use already a long time ago, actually since the concern of ActiveX and COM objects started to stable in 151 PTF6. As I remember, you started to see people using XML more and more in Team Developer using ActiveX. So we are talking about MS XML 3, 4, 5, and 6. The version 5 is distributed through MS Office. There is a recent version 6. So this is for ActiveX, right? As ActiveX, because this is oldest technology in a way that could be used in Team Developer, this is why maybe I should have put it in the first place. You can actually, you don't need, you know, .NET to actually manipulate your XML. You can use Win32 via COM, and just for your information, Microsoft 5.0 still support version 3. You can build a target using Win32 COM objects simply because we do support COM objects with something called COM interrupts in .NET. But if you look at on the internet, it's not recommended, it's not supported by Microsoft. So if you do have a Win32 application and you're going to have to move to .NET, you're going to have to convert the MS XML to .NET. I will show you in performance that I did the exact same first program that I show you using all those different technologies. They have TD-XML, which, if my memory serves me well, came in version 4.0. I'm not sure anymore. This is an interface of team developers to XMLib.apl, which uses actually the Xerces XML engine. It's only valid for Win32. There is no .NET target. So, you know, if you need to update or migrate to .NET, you're obviously going to need also to convert it. The good news is that it looks exactly the same. The object name are the same, a bit different, you know, in terms of there is no underscore or whatever. It's exactly the same. So you're going to be at home. It shouldn't be a too much difficult task, you know, to convert from one engine to the other one. NetXML. I want to say, yeah. Here I wanted to say that it might be interesting to know if the technology MS XML6, which is the latest one, which is also accessible through COM, is the same or is the same engine as .NET. No, it's a totally different engine. Actually, they're competing, right? Some features that exist in one and not in the other one, but MS XML6 is pretty much online, as far as I know, in terms of feature comparing to .NET. Okay. Other engines, we were talking about the DOM, document object model, but there are ways also to read XML file and to write XML file, but actually just loading it in memory and simply read it linearly as it is a file. So it looks like SACS, but there is some subtle difference. I'm not a pro in SACS, but I know how to read the internet, and hopefully what I read is correct. But basically, you have a bit the equivalent, which is System.Xml.XmlReader, which is a good choice for performance. It's a bit friendly in terms of API, richness of the API. You only go forward. You cannot edit the value of an attribute or content of an element, cannot insert and remove node. It's a poll model, not based as SACS. Looping, reading an XML stream, checking node type. So it's pretty much you load the stream and you just process the stream by reading. While SACS actually is using the push model. So that means he's going to send you an event and you're going to process if you have a text element or kind of things, right? There's also some other engine, which there's definitely no time to talk about it. I think it probably will be interesting. LinkQ is very important in Visual Studio and in .NET. So it's another way of accessing through XDoc, the XDoc object, UXML. But we're not going to talk about it. Performance. As I say, the first program that I documented, in the slide, and then I show you run the recursive example. Over here, you can see its version in TD.XML, so using XML exercise. Here, COM object, and here, .NET DOM, the DOM engine, and then same with Reader. Now, we're talking about engine. There are clearly some airliner, and there's clearly some jet fighter over here. So you can see those two are definitely jet fighter in comparison of the other one. Can't believe it. I mean, it's a 1.6 megabyte file, 16 seconds, versus not even hundredths of a second. So it's quite amazing. But this slide is nice. The thing is that it doesn't necessarily tell you truly about the performance of the engine. Well, what it is, it's because the two over there are Win32 application, right? Obviously, because it's COM, and I didn't bother to convert it to .NET because it's not recommended to use COM XML in .NET. So those are Win32 one, and those one are truly .NET applications, so with .NET Target. And you remember that we were talking about the just-in-time compiler. This is definitely where the performance kicks in. It's a bit more difficult to compare the performance with the DOM engine, simply because, yes, those are issues that I know currently that we will address, that I could not convert this application using Gale. This could be part of a side of a limitation, because often we need to cast, elements and things like that. So basically, there is a problem. So the comparison is fair if you compare Win32 with .NET, and you can see the benefits in using a fully .NET Target. But it's unfair if you would compare Win32, or if you would try to compare the performance of the engine. Well, .NET XML is supposed to be really fast, and in terms of memory performance, as opposed to Java, for what I could read. Now, there's going to be a demo about System.Xml.XmlReader writer. I don't know what time is it. It's already 5:54. I'm going to have to stop. I cannot even comment that. So let me go very quickly in that. Let me close my slides and let me go in my samples. Webinar. Okay, now I'm going to go here, and I'm going to go to this one. So let me just show you what this application I did. And again, I'm not a developer. I'm a Rust in XML, and believe me, I was quite surprised how simple this thing is. Right over here, basically what I'm doing, let me delete the object grade, let me delete this guy, let me delete the grade.xml. Basically what I do here with the XML text read and writer is I can populate, this is a basic saltbl populate the Eastland, and what I can do actually is to generate the XML. So if I generate the XML over here, you can see that the grid.xml has been generated, and I also, every time I generate it, display it in an ActiveX web, Internet Explorer web object, right? What I can also do, for example, is to generate attributes and so on. The other thing that is interesting with this application, because we don't have much time, but I really wanted to show you that, is actually debugging this application. Let me go there. Let me attach to the process. I have to attach to the process because over here I'm going to call an assembly method, okay, that is going to return me Noratal result set. So let me go there and let me attach to this guy over here. Over here, actually, I had quite some problem to debug because assembly needs to be loaded. All right, so this is my assembly that I wrote, and the assembly is a store procedure that returns a result set. Well, I pass you the. It's also use the document, right, object to actually generate the data set from our result set, right, which is on top of that the store procedure. So let me try to debug this guy. So I click there, and then I go to my con open. Yeah, and then I'm gonna step over. Right, and then simply return, continue, and then simply return my XML. So they can get populated now with the function that I did into my grid. For example, I can also change, but the end no as an attribute. Actually, table would be good. It would better to be ID. So there is that. Also, well, it's no point. What you can do is to export to Excel. This has nothing to do with XML, but those are features of the grid while we are at it. So see here that I have this. So basically, me that I'm a support. I'm supposed to know about multiple technology, but I can be totally a pro in one of them. Totally, yes, a pro. I'm out there, using Team Developer that knows very well XML. But I was quite surprised. That was not that complicated. So the most important actually is to to practice as much as you can XML because it's really important. So I lost my slide, so let me go at the end and we'll conclude my presentation. I wish I had a bit more time, and now it's the moment for your questions. Thank you.
Well, thank you, Jean-Marc. And again, if you want to post a question, on your WebEx toolbar is a question mark on it. It's the Q&A button. Use that button to post a question, and we will go through them. Thanks.
Hello?
Yeah, there's no question at this point. So with that, we'll just start finalizing here the webinar. We want to thank everybody for participating. If you do have a question, there's still time to post it while we wrap this up. But again, we want to thank you for attending the webinar. We hope you found the information useful. And we will have a recording of this webinar available on the website tomorrow, actually. And you can find that on our blog, TD Wiki community, or I believe you might also be able to find it on our unify.com website as well under news and events. There's a way to access recorded webinars. Let us know when you leave the webinar. There's a quick little live question survey. Let us know how we did and if there's particular topics you'd like to see in the future. And Jean-Marc or Martin, do you see any other questions that have popped up?
No.
Okay, well then with that, we'll go ahead and close down the webinar and have a great day, everybody.
Thank you, everybody.